We went live yesterday with what we call, how do we call it now? AGRIS 2.0.
Yeah.
AGRIS 2.0. It is the conclusion of our experiment with OpenAGRIS, so one of the first linked open data applications in we want to show now you what we have done with AGRIS. It's announced in AIMS as how to search bibliographical data, but you will see it's much more than bibliographical data now. And so what we have prepared here is you will have a presentation, Fabrizio?
Yeah, I will have a presentation about the backbone of AGRIS, because it's important to understand how the data flow through the application and how we are able to interlink to external sources of information to understand the power of this tool.
Okay, then I will show you yeah, just the test search and what is happening and what data we will get, and to introduce a bit changes and new functionalities. And then we would like to get a lot of feedback. Feedback now in this webinar, but also feedback after. Don't worry at the moment about look and feel. We just, the only, I think, great thing what we did with look and feel, we finally put the AGRIS green on the screen, but everything else was this graphic we know has to be redone, and we have to work on this. But we wanted to go out with the functionality, not because we think it's perfect, but just from the contrary, we want to get feedback as quick as possible from all people who like AGRIS. And these are what I saw in the statistics last month, 260,000 persons who were using the AGRIS application. Okay, not losing more time from my introduction, I give the mic to Fabrizio, who will show you a bit about what is behind the scenes.
Thank you, Johannes. So, first of all, some words about AGRIS. What is AGRIS? AGRIS is a lot of things. We can define AGRIS as a network, as a website, as a search engine. But AGRIS is also a database, and now AGRIS contains more than 7 million bibliographic records in the agricultural domain, and most of these references are enhanced by the AgroVoc thesaurus, which is very important. AgroVoc at the moment in the new implementation of the system is really the backbone of the system, since our idea is to build a portal where we store bibliographic references in the agricultural domain, but we are also able to automatically extract from other web sources related information. And AgroVoc is the way we can query external dataset. So as I told you, the idea is that when we discover bibliographic references in the AGRIS domain, we store these references in the AGRIS database. Otherwise, when we discover other kind of information like videos, pictures, statistics, and graphs, we can interlink AGRIS to this information without centralizing everything. So the new AGRIS search engine has a distributed approach where we have a central repository that, thanks to AgroVoc, is connected, is interlinked to a lot of other repositories all over the web. AGRIS can consume metadata, so bibliographic references, in two ways. The first one is pooling data, harvesting from clients, for instance, using tools like IPMH Harvester, but this means that this metadata should be provided in a standard way using open protocols. The other way is pushing data to AGRIS from clients. And some examples are national libraries or journal publishers. The case of the journal publishers is a little bit different because most of the time they knock to our door in order to publish their data, since AGRIS has a lot of visibility. We have in this period, we have more than 300,000 visits per month. And then we are also indexed by Google. And this is very important since when you type over Google query in the agricultural domain, we are between the first results. So we have a lot of visibility, and journal editors want their data to be published into AGRIS. This picture explains you a little bit the flow of the metadata from the data provider to the AGRIS application. The main idea is that we don't want to force any data provider to give us data in a specific format. We try to accept everything. But this decision requires a manual work because at the beginning, we need a communication with the data provider to understand which is the data format of their metadata. And then we have also to create a mapping between the data format of the data provider and the AGRIS internal model that now it's completely RDF. Then we developed also a small tool that we call the AGRIS input application, which contains all these mappings that we manually create, and that is able to translate the data format of the data provider to the AGRIS internal model. Then there are also other manual operations. For instance, we have to randomly check for inconsistencies inside the metadata. We have to check for errors. Sometimes we modify something. For instance, the AGRIS input application is also able to standardize the format of the dates in order to have dates in a common format in the entire repository. After all this management of the data, of the metadata, we can store this metadata into the database, which is at the moment triple store since the internal model is RDF, and also in another place, the Apache Solar Index, which allows the user to query the AGRIS search engine. So this other picture explains you a little bit the functionalities of the AGRIS input application. Starting from different sources of information and different data formats, the AGRIS input application does a lot of work in order to store RDF into the triple store and to index it into the Solar Index. Then the AGRIS search engine will read the Solar Index when the user types a query, and the triple store to create the magic of the interlinking through AgroVoc keywords, and we will see it in few slides. Another important tool is the AgroTagger. In fact, since AgroVoc is the magic, which allows AGRIS to interlink to external dataset, it is important to have AGRIS references indexed using AgroVoc. But the most of the time, we don't have AgroVoc keywords. We can have free keywords, but not AgroVoc keywords. And sometimes there are no keywords at all. So this tool, the AgroTagger tool, is able to read the entire publication, so the full text of the publication when available, to automatically extract AgroVoc keywords using this algorithm called MAUI, and to generate triples indexing an AGRIS resource with some AgroVoc keywords. Another problem is that most of the time we don't have the full text of the publication. So we are trying to have an agreement with Google to use the Google Custom Search APIs. In this way, when we don't have the full text of a publication, we can use the Google API to look the full text over the web. So the AgroTagger can work directly on the full text extracted by Google. I told you before that we convert the input format into the AGRIS RDF internal model. There is something to say about the word model. Since using RDF, we don't have to attach to a piece of metadata, a DTD or a schema, so there is no validation. And ideally, a model can contain every RDF properties. We define a small subset of properties because we have to train the AGRIS input application how it can convert the input format into something else. So for the moment, as you can see, we choose the most common properties all over the web. So we are using Bible to describe bibliographic resources, FOAF to describe person and organizations, and Dublin Core for the other field that we need to model. This is a simple snapshot of an AGRIS RDF XML record. And this is very important because, as you can see, we can manage RDF as it was XML. So we maintain the interoperability with other systems. And this snapshot shows also that we have a lot of URIs. For instance, we have the URI of the journal where this article come from. In fact, we have also a dataset of more than 20,000 journals whose articles are indexed in the AGRIS repository. We have also the URI for the record, and we have URI for AGRIS keywords. We don't have URIs for authors because we are still trying to disambiguate our authors. We have a lot of authors to disambiguate, and this process is not so easy, but this will be a next step. So the provenance is a big issue. In fact, in open world systems, data is designed to be accessed potentially by any person or machine, and we have to understand the source of the information. AGRIS contains implicit information about the provenance in the record identifier, which is called ARN. When you talk about provenance, you can create a chain of provenance from the entity which creates the first piece of metadata to the last entity which sends us the data. In the AGRIS database, we have only the last string of the chain, so the information about the data provider which gave us the piece of metadata. In the slide, there is an example. In this situation, we have this number that refers to the AGRIS center in Italy. There is also the date of the submission of the record. So for us, this is the provenance, the AGRIS center and the date, the last chain of the last string of the chain. And then there is also a progressive number which can identify the record inside the set of the data given from the same data provider. Some information about the storage system. The AGRIS RDF currently stored in Malaysia at Mimos, and we are using an Allegro Graph triple store. Currently, we have a computer with 90 GB of RAM, and we are still testing this computer. In fact, until last month, we were using a machine of 32 GB, but at least once a month, Allegro Graph went down for different reasons. For instance, pending processes, for problem of memory. At the moment, we are not, there are no issues, but we are still testing the new architecture or also other solution. For instance, there is another good triple store called Aulim, or we could think to use also NoSQL databases. But we need to model AGRIS data as RDF. Then the architecture needs to be tuned, and we are working on this. Oh, let's talk a little bit about interlinking and the AgroVoc magic. We have seen that AGRIS centralizes bibliographic references, and I told you that AgroVoc is the backbone of the entire process. Using AgroVoc, and especially the AgroVoc alignment to other thesauri, we are able to query external Sparkle endpoints, external web services, and APIs, obtaining some results that are semantically correct the most of the time. Why? Because if we have an AGRIS record indexed with some AgroVoc URIs, no more simple keywords, but URIs, we can use external repository indexed with other thesauri, for instance, aligned to AgroVoc, and we are sure that the information that we extract from these repositories is related to the AGRIS record that the user is looking for. In this way, we are able to create a set of widgets to display in the AGRIS page that we call a mashup page. So the user has in one page a lot of information. The AGRIS record he was looking for, and a lot of other information, statistical information, distribution maps, and pictures, other references, other articles. So everything in one page without the need to go to Google and look for other resources not indexed in AGRIS. So the procedure is really simple. We have to discover external resources. We have to align agrovoc to other thesauri, and then simply write the code and interlink. This is an example. I called it the IFPRI case. In this example, the user is querying the system, the AGRIS search engine. He finds a record with some agrovoc keywords. If between these keywords there is at least an agrovoc term related to a country, we are able to query the IFPRI Sparkle endpoint, getting information about the global hunger index and the child mortality rate in the specific country. So we can create this box, this widget, and show it directly to the user. These are some numbers. At the moment, we have 7.6 million bibliographic records. We have more than 180 million triples. We have 3 RDF datasets, since, as I told you, we are modeling also the AGRIS serial dataset and also the AGRIS center dataset, which is the dataset of the data providers. And we triplified the information of all the AGRIS data providers. And this is the last slide, where I want to show you a little bit how the process goes. Starting from an AGRIS record, so the URI of an AGRIS record, we query our internal Sparkle endpoint to retrieve information about the AGRIS center, the serial, and the list of agrovoc URIs associated to the record. Once we have agrovoc, we are able to query external APIs and external Sparkle endpoints, and to build on the fly. So this is all dynamic and automatic. So we build on the fly a set of widgets to display this information. And that's all.
Okay, thank you. Thank you, Fabrizio. I want to go now into the application. And we are already, what you're seeing here is the new AGRIS homepage. What we wanted to do is giving directly content on the homepage. If you go here and click at example one of these records, you immediately get an OpenAGRIS record, which I will explain later in more details. What should we do? Is anyone from you with a proposal for a search? Okay, speed it up. I will do my my preferred search. Let's go very global. Pesticides. Yeah, ex-pesticide chemist. So what you get here is 76,300 resources. This is not where you want to work with, because also normally questions are more precise than about pesticides. But what we see here on the right side is something about refine your search. And then there are agrovoc, keyword, countries, content. Fabrizio, can you explain a bit what this is here, this refining your search?
Yes, the idea is that we want to give to the user a simple way to filter the results that the AGRIS search engine return, in order to don't lose the mind inside the thousands and thousands of records. So, given this result set of 76,000 results, the application extracts automatically the 10 most used keywords, agrovoc keywords, inside the result set. So not inside the whole repository, but only inside the result set. So the user on the right can see the 10 most used agrovoc descriptors in the result set. And he can click also on one of these descriptors in order to refine the search. In this way, the user will have less results to look in and more semantic, and it will have a more semantic value to this. So we do this work both for agrovoc keywords, for country names, and also for the type of the resource. So you can filter your record, your result if you want, for instance, only bibliographic data or chapter of book or conference article. There is a box on the right and you can simply filter. So we want to give the user the possibility to filter the result set in an easy way.
Okay, good. Because you know this research is always done. People only use simple search boxes and then they see only the first page. But for scientific use, this is not the correct way to go because we have to see more in detail what resources are there. And so what we try here is to use the AGRIS structure to make it easier to get to more precise and narrow results. But I want to show you first also something about the linked open data qualities of AGRIS. You see here data from Europeana and data from Nature.com. I think both Nature, I know they publish their data set as RDF. Yes. Europeana is also an RDF data set?
Yes, but we are querying their web services because they are faster at the moment in their architecture.
Okay, so we have AGRIS and RDF, and we are very happy if we find other RDF data sets because it's very easy to query them and to link them to AGRIS. But if there are other data sets, we also use different methods to link them. But okay, you see here already linked to the record set, not to a single AGRIS record, about from different sources. Okay, but let's go for we want to know something about residues. And now I have still my query about pesticides, but you see there is residues. And this is still a lot, and I'm more precisely interested in pesticides. So at the end, what I want to get is about pesticides in herbicides in Italy. But here at the moment, I see no Italy in this list of descriptors. So how I could easily more narrow my research, because we really try to make it as easy as possible so that you can, on this view, compose your query simply by clicking. But if this is not enough for you, you can go to a classical bibliographic data view. You go to this classical view, and you see here, you transport the agrobog filters of residues and pesticides. Where's my herbicide? Let me go back to see what I did. Pesticide residues. Okay, I didn't put herbicides, but I want to get. Oh, actually, I don't have it here, so therefore I don't have it. Okay, we go to the classical view, and now I can do what I want. I say, okay, I want. Let's stay with agrobog, and let's say agrobog terms, and I say herbicides. Refine search. Look, it adds herbicides here, and I get down to 479. And so I can't imagine there is really nothing about Italy. Let's try. And let's go again about agrobog terms. Italy, refine search. And I get one record. It's not really satisfactory, but it's just one of the biggest Italian herbicide problems, the residues of atrazine, alachlor-trifluralin in soils. But maybe I can go away with pesticides and got more. So relatively easy. I have gotten my I have reduced this to 7 relevant articles about herbicide residues in Italy. Now, this was simply a nice way in querying AGRIS. Now let's go. let's still go to the residue article. And now clicking the resource here brings you to the OpenAGRIS. And what you see here, all these circles who are circling are linked open data. And what we get here, you see on the left side, this is a traditional article. On the right side, you get everything what is linked. In this case, so much. You get the nature article, you get something about Italy from DBpedia, and you got the FAO country profile articles on Italy. Because linked open data is an open world approach, so it does not mean that you get always the same result, or you get not always results from all the data sources. And so I want to show you another example where you can see a bit more. I go for Tunis or Bezos. I get my, okay, I get 1,300 results. It's still a lot for one fish. But you see, if we want now, we could limit this to Tunis or Bezos in Indian Ocean. You see here, it's very interesting that you can also see the weight of the combination of certain topics together in this way. But I don't go into a more difficult search strategy. I go simply to the first resource that I found, and it opens the Tunis or Bezos article in words, which leads you to the AgriVoc linked open data pages when you click them. You get the source, which is from the where is this from? From our triple base on
of AGRIS data providers.
AGRIS data providers, and you get here the Google linking, the Nature linking, the DBpedia linking. What in this case is already more interesting for some users of AGRIS. But what you get also here is data from the World Bank, data from GBIF, the Global Biodiversity Facility, and from FAO Fisheries Statistics. And this you get without that you had to search for it, because we simply exploited the semantic relationships between our AGRIS record and other sources on the web through AgriVoc mappings. This is not all. We are, how many data sources we have at the moment linked?
12.
12. But we have here only 1, 2, 3, 4, 5, 6,
yes.
Because it depends on the record. I show you something else. There mice. And okay, let's simply take the first article. And I hope that you can see now the latest results of our collaboration with Bioversity. I hope they are on. Because we linked to the biodiversity germplasm database, which is also published as RDF, and we should have direct access to germplasm data. Let's see if we get something better. Yeah. No.
Probably they have connection problems, because I saw the circle, but we don't get results. So probably they have problems in the Bioversity server. But I think this is normal when you use linked open data, because you rely on your central database to show your data. Then when you have to interlink to other data set, you have also to rely to the stability of their server and of their servers. If they have, for instance, connection problems in a specific moment, you can see the piece of information. For instance, this happens very frequently with Wikipedia. They don't have money anymore, so they are not managing anymore their resources, and most of the time the server is down, so sometimes you don't have results, and this is what happened now with Bioversity, I guess.
Yes, because biodiversity is obviously not accessible, because what we have done, something very simple, we mapped, I think, the species name, the scientific species name
yes,
from AgriVoc against the scientific species names in the passport database of biodiversity, and now we get passport expedition data for germplasm with related AGRIS records. This is information that is very much digged into deep into websites, what we could get open through linked open data technologies. This is obviously open. We can link, we now have linked 12 resources. We can also link 120 resources. And this obviously poses some questions. Maybe Fabrizio, you can give a little glimpse what we can do in the future.
Yes. In the future, we would like to give the user the possibility to customize this view. Since for the moment, as Johanna said, we have only 12 sources of information, so it's quite easy to display everything in a single page. But if we had, I don't know, also 1,000 of sources of information, it would be really difficult to show everything and to let the user understand the content of a web page. So using user database, so if we allow the user to register the website, the user can also choose from a customization page which data sources he wants to see in the mashup page. In this way, the user will filter the set of data sources, and we could have a lot of external sources of information to display, and the user can choose directly the ones he needs. For instance, if the user is a scientist, probably he would want to see data from the Wikipedia, that is the RDF-ization of the Wikipedia, but probably wants to see only scientific sources of information. So the idea is to have a portal where the user can register and customize the final view.
Okay, we just can demonstrate you another problem of linked open data. We just showed you that sometimes resources are down, like the biodiversity database on germplasm, and now also Google disappeared from our results.
Yes, but this is another point, because Google is not using linked data and RDF, but Google gives us a limited number of queries per day. We have 30,000 queries per day, and after all the world has performed more than 30,000 of queries, we don't have anymore the Google widget for the day. So this means that today we are reaching the quota.
Yeah. Okay, and this is and we have to negotiate this with Google always new, and this means that linked open data paradigm is something where you need institutional agreements, and it's not simply that you dig into the cloud and you get something out. We have discussed already 3 problems: Wikipedia, the stability of some sources, and economic agreements with some. Exactly. And these 3 topics have to be handled if you want to make successful linked open data applications. I want to finish here with our talking. I think you can explore on your own the application, and we are very happy if you then click this here and give some us feedback about what you think, what we should improve. You will find some more a material here what is explaining AGRIS, and this will grow. We have not completed everything what we want to complete because we wanted simply to go live before the end of the year, because as we think the best testing of an application